I'm Mohamed. I work for Zulily. I'm the lead engineer in the e-commerce platform team. Today I'll be talking about how did we use Redis as a persistent data storage, exactly to the point of Yiftah's keynote that Redis is not just a cache, it can also be a completely data storage. Today I'll be talking about how did Zulily do its customer session management using Redis as a data storage. So what is Zulily and why did Zulily create a specific technical cases that was challenging for the engineering team? Zulily is not a typical e-commerce where basically our business model is driven by discovery. So you don't come to Zulily with an intent to buy. You come to Zulily with an intent to discover new products or to have fun. It's like going to a boutique or going to a mall. You come there just for fun. You might buy, you might not. All our products are less than 72 hours, which creates like some technical challenges for us. The nature of the traffic to Zulily is basically very spiky, which means that the typical approach of just using a database and a cache over it wouldn't work normally for us. Zulily is very, very personalized, which creates another technical challenge for us. Like you can think about it that we launch technically millions of sites every day. So here's the problem that we had is because it's all about discovery, the session of the customers is very important for us, that the customer stays within the session for some time. If it goes down, the whole site is down, or the whole site from the point of view of the customer is down. And especially when we moved our system to the cloud and everything failed in the cloud, that was very challenging for us. So what's the problem that we had? The problem that we had is our session management service was not very reliable. And it's the cloud, so things go down, Redis goes down, EC2 goes down, and that would impact our customers' flow on the site. And that was not acceptable, especially that we were planning to move across the world. So with all the experience about discovery, that wouldn't work for us. We had a very typical architecture that handled the session management for Zulily, a very similar case that I think most of you have used before. It's basically the clients here for us will be the site cluster and application cluster that had a container of Twin Proxy on every box. For not bombarding Redis with tons of connection. Our sharding logic was embedded within the application logic, so that had a limitation for us that we cannot scale the Redis nodes without changing the code. We were using the typical approach of a master and a slave node, so the data was distributed across multiple master nodes, and we had a replica slaves across each of them. In case of disasters, we promote the slaves to master. So what's the problems that we were facing almost every day? Either we see a network degradation because latency is high, or we see a complete failure if one of the master nodes goes down. So that would literally cause the percentage of customers that are sharded on this node to be not capable of smoothly discovering what's on the site or what's on the apps. And that was not acceptable by us, especially because of the cloud, especially because of the global expansion. Then we started thinking about multiple approaches. How can we fix this? Two things that came to our mind was, why don't we use just Redis cluster? But the limitation for us was Redis cluster wouldn't survive under major network partitioning, which was one of the cases that we saw. We actually saw 2 times that a complete region of AWS goes down, which led to an outage in our system for hours. So that option wouldn't work for us. The second we thought about, so why didn't we use Redis Sentinel to promote the slaves to master automatically in case of the failure on the master nodes, or in case of network degradations, or in case of any issues that happen on the master node. That would work, but that will still couple our application logic, sharding logic within the application. And also the time to promote the slaves to master is maybe a few seconds, and that wouldn't work for us. But because again, our business models hold about a smooth discovery on the site. So that's the approach that, or that's the solution that we proposed. It's basically, we replaced the twin proxy with our custom proxy. And we completely abstracted the session logic from the application logic to its own scalable service. We call this the session service. And then we replicated Redis across multiple regions in AWS, and we used a ring-based system. I'll talk in details about the proxy, the service, and the topology of how we distributed Redis across regions. So why did we need a proxy? Why didn't we just use the current thing, like either twin proxy or no? Because twin proxy was basically doing connection pooling between the clients and directly with Redis. As we abstracted this to a service, twin proxy wouldn't function well. And you would really be surprised the TCP connection establishment time, how less performant it was before the proxy. So we used the proxy for either connection pooling, collecting metrics, and having a limited number of connection and the latency of establishing a new connection. Then here was the logic of our session service, or why did we need this session service? We basically used the session service, which scaled horizontally, for sharding the data across rings. So we considered, or the approach was, a single ring will have a complete data set of our sessions, which is in this case A1, B1, A1, A2, A3. So the data would be distributed across A1, A2, A3 based on murmur hashing. The service was aware about the topology, or was aware about the regions or the data centers, was aware about the health checks of every node of Redis. And here was our topology of distributing Redis across data centers or regions. We use Dynamite, an open source Netflix framework for this. What I mean here by data center, it could be just a complete set of, it's like a virtual meaning for me that a complete set of data will be in this data center. So it could be either a region, it could be an availability zone, it could be its own cloud provider, either AWS, Google Cloud, or even your on-premises. But the whole idea is every virtual rack will contain the complete data set, which will be A1, A2, A3 in one of the cases here. Same with data center 2, data center B. So here how the request would come. Like the request would pass to the session service. The session service would understand based on the hashing which part of the node it should go to, either A1, A2, or A3, or B1, or B2, or B3. So let's say it should be either an A1 or B1 or C1, because the system is replicated across these data centers or regions based on Dynamite. So it comes to A1, it will be asynchronously replicated across these multiple data centers or multiple regions. Same if another one you want to read from another hash, it will go to either B2 or A2, but based on the most closest node to you and the most healthiest node to you, the data will be replying back. And again, the replication will be happening. It was very challenging for us to roll out this to production, because it was Q4 for us, and that was, you guys, like e-commerce is That's the most critical time in e-commerce. So how did we think of rolling out this to production? How did we gain the confidence of rolling this out? So we start to think that, okay, let's replicate or get the whole data from the slave nodes that we had in the previous architecture and move it to the new architecture without any reader writes to it. And starting from this point, we started to double write to the both systems. So the application was writing to the old architecture and the new architecture. And then we started to double write from the old architecture and the new architecture. And because of the criticality of the data, we had to sanitize to make sure that the data is accurate like 100%. And as soon as we verified the data is correct, we started to read from the new architectural and apply chaos engineering on it. So how did we apply chaos engineering and why did we apply chaos engineering? To recap, our main problem was the cloud, was failures, was data centers go down or zones go down. So the whole team went to a room and we started applying chaos over our nodes and our regions and our zones. So we start by killing EC2 instances, we start by killing Redis nodes, we start by introducing network latencies between the data centers or the regions in this case and our application. And the end result of all this chaos for us was we literally took down 2 of our regions completely out, which means like 2/3 of our nodes were completely out of service. And here was the result, that the latency of the P99.9 didn't actually get affected, which was still under 7 milliseconds with all this network hops that happened. Our failure rate for a time window of 250 milliseconds was only 0.4%. If I compare this with the old architecture, that would literally cause us an hours of outage to get back to the system. Okay, so no architecture is perfect, and here's what I believe is the problems that we had with this architecture, or what's the drawbacks. If you want to scale the system, as I described, it's all about rings. So scaling a new Redis node, you basically need to multiply this across the data center or the regions that you have. We introduced higher network traffic for the new architecture because we had a proxy talking to the load balancer talking to an EC2 instance, then talking to Redis, then Dynamite replicating across multiple regions. The cross data replication across regions or data center is expensive. So it gives you high availability, but it is expensive money-wise. For us, adding data to the rings is a manual process that can be automated, but in the current state, it's a manual thing, which means that you have to offline reshard all your data across the nodes. Okay, recapping everything here, that's the summary of what we had. Use a proxy for establishing the TCP connections. It will for us, it saves us at least 70 milliseconds, so it's magnitude of tens. Abstract your sharding from your application, move it to a horizontally scaling service. Understand that Redis is not just a cache. If speed is critical to your application, use Redis as a primary data store and make it highly available. There's multiple approaches to do it. One of them was replicating across multiple data centers or across multiple regions that we used. Design your system for failure. Understand that the cloud is a chaos. Everything fails. That's everything that, as engineers, we face every day. EC2 instance goes down, network slow, boxes fail, completely data center goes down. So that's our day-to-day work. So design your system based on this. Replicate your data across multiple regions, availability zones at least, regions if you can, across data centers if it's possible for you. And that was Our second approach, because as we are expanding across the world, we wanted the data to be closer to our customers. So that's why we had to do this. Thank you very much. And yeah, if this kind of problems interest you, we are hiring. Thanks.
Okay, we do have a moment or two. I saw a hand. Did you want to ask a question?
Yep.
Okay, here you go. Wait, hold on one second. Are you available for questions?
I'm available for questions.
So you mentioned Redis Sentinel as a possible solution, but you said there was a drawback to it. How is having just replicas of your Redis cluster a different solution than having Redis Sentinel implemented?
Okay. So Redis Sentinel is still an active passive mode. You have a primary Redis node and you have a secondary Redis node that is not active. And what would Redis Sentinel do for you is, in case of the failure of the primary, it's going to be promoting the slave to the primary. Which would work, but would take some time. And that we will still be in active passive mode. We wanted to be able to scale across. That wouldn't give us that option. And the sharding logic will still be in our application, so that wouldn't work for us.
Okay. Very good. Thank you for the questions. All right. Mohamed, thank you very much.
Thank you very much. Thanks, Dave.